Right, I guess I'll just go ahead and start. So the topic of this talk is going to be building.
Too close to the mic.
Oh, am I? Sorry. So it's going to be building decentralized applications in ClojureScript. I'm hoping that you are not too sick of blockchain yet, because that's what this talk is going to be about too. So just to briefly introduce myself. So my name is Derek. I currently work for this company called DFINITY, which is also a startup in the blockchain space. So the high-level breakdown of my talk is basically that it's going to be having two components. So in the first component, I will be introducing sort of like the high-level key concepts that you need to understand in order to develop decentralized application. And then in the second part, I will be walking through sort of like the complete example of a decentralized application. Right. So what are the key concepts? So the first concept is going to be blockchain, and thanks to Alex, I probably won't have to spend too much time there. The second concept that Alex didn't touch upon is Ethereum and smart contracts, which I'll be talking about. And then we'll be talking about what we mean exactly by decentralized applications, or more commonly just known as dapps. And then we'll go into specific technologies such as Web3.js and MetaMask that are very important in building decentralized applications. So what is blockchain, right? So I think Alex went into sort of like the how of blockchain, so like how it works. But if we try to answer sort of like just like what is blockchain, I think the simplest explanation I can come up with is that a blockchain is really just an append-only log, right? It's really just a data structure, that's an append-only log, that everyone in the blockchain network agrees upon, right? So if that's a blockchain, then what is Ethereum and what is a smart contract? So Ethereum is essentially a collection of state machines that are more commonly known as smart contracts. And we already mentioned that like a blockchain is an append-only log. So in Ethereum, the blockchain is basically an append-only log of state transitions. Right, so like here you can see like a demonstration of how Ethereum works. So on the left you have like the state of Ethereum, which itself is consisted of so here you can see four boxes. So each of these boxes is a smart contract. And when Ethereum receives a transaction here, it's kind of transitioning into another state. Right, so it's actually just like a very simple state machine abstraction, which I'm sure most of you are familiar with. So now, what is a decentralized application, or dapp then? So a dapp is really nothing more than an application that happens to interact with smart contracts, right? So here we can see the architecture of dapp. So on the left we have the user interface, which is really just like either a web page, it can be like a mobile application, a desktop app. And then on the right, we have all these smart contracts and Ethereum, and they interact using this technology called Web3.js, which is really just a JavaScript library that we'll go into. So again, Web3.js is really just a JavaScript library that's your typical web application can use. So here I'm showing you some code snippets for using Web3. So here, sort of like the point that I'm trying to show is that it's really just normal JavaScript, right? So here we're doing web3.eth.getBalance, right? Which will tell you sort of like the balance associated with an account. And then here we are deploying a contract. So sort of like the idea here is that to interact with the blockchain, you get to just write normal JavaScript, right? There's no magic. But there's sort of like the last piece to the puzzle, right? Which is how does your browser actually talk to Ethereum, right? Because like your browser is this application sitting on your laptop, and then Ethereum is this like decentralized network of computers running somewhere, right? So like how does your browser actually talk to this network? So the way it works is that your JavaScript code is going to call into Web3, and then Web3 is going to make RPC call to a Ethereum node, right? So now the question becomes which Ethereum node? And the answer is that like when you initialize Web3, you would basically like give it an URL. So like right now, so like right here, I'm telling my browser that that they should connect to an Ethereum node that's running on localhost, right? But it could be anything. So there's like one last technology that we need to know before we can get into the development, and that's MetaMask. what MetaMask is what people would call a dapp browser. And what it really means is that it's really just a browser extension that proxies the Web3 RPC calls to a remote Ethereum node, right? So here we can see the architecture. So you have the client application here, which calls into Web3, and then MetaMask is gonna sort of like capture all the RPC calls and then redirect RPC calls to some remote Ethereum nodes. And the motivation behind MetaMask is that basically, like it would be unreasonable to expect every user of your decentralized application to be running an Ethereum node locally, because running an Ethereum node is actually a pretty resource-intensive process, right? So, right, because like your dapp user could be, like using a mobile phone, could be just using a browser, right? So they may not actually have the resource to run a full Ethereum node. So those were like the high-level concepts that I wanted to introduce, before I get into the coding part. Was there any sort of like questions about the concepts? Also, should I be speaking into a mic or should I be sort of like?
You're too close and you're too loud.
Oh, I am.
And you're too fast.
Oh, yeah. Okay. I'll try to slow down. Sorry. Yeah.
The mic is really weird, by the way. It's like hard to do, just in general. Like I was talking at me. Sure. For me too.
If I just talk normally like that,
that's a good idea.
Okay. For some reason, like my own voice, it just sounds really low to me. So which is why I'm trying to speak into the mic.
And also, does MetaMask solve the problem of having a wallet that they can use for
yes.
all different applications?
Yep. I can actually show you right now. So like this is MetaMask. Text is real small. I'm not sure if you can see it. Can you see it? I'm not sure if I can zoom into the. Yeah. But yeah. So if you can see the number here, yeah. So basically it's telling me that account 8 has like 100 Ether right now. That's how MetaMask look like. It's an extension. Any other questions? Cool. So now let's get into coding. So to build a decentralized application, basically like there are 2 steps. So in the first step, you'll be writing a smart contract, and then in the second step, you'll be writing an application, and in this case, you'll be writing the application in ClojureScript. So how do you write a smart contract? So the application we'll be building today is going to be a decentralized tutor, right? So it's going to be a dapp that mirrors the tutor's functionality. So here's here's the smart contract that we'll be using. So smart contract is typically written in this new programming language called Solidity, which stands for implying that the language is very solid. But even though it's like a new programming language, as you can see, it's actually pretty similar to most languages you are probably familiar with, right? Such as like JavaScript. So because the contract is so simple, we're just gonna be walking over it line by line. On the first line, we have contract tutor, which is saying that okay, so this contract is gonna be called tutor. And then on the second line, we are saying mapping public tweets. And what that means is that we are declaring a variable that's of the type mapping. And the mapping is really just like a dictionary in Python or like a mapping in JavaScript, right? It's just like a map. And this mapping in this case is mapping from address to a list of strings. And the idea here is very simple, right? So so every user of this decentralized Twitter is going to be identified by their address on the blockchain, and then we'll be storing their tweets as a list of strings. So that's the storage. Makes sense, right? And then the 2 functions that we'll be using. So the first function is going to be count, which takes an address and returns a unsigned integer. And the idea here is that like given a user, we want to know like how many tweets they've made. And the final and most important function is the tweet function. So the tweet function takes a string, right? Which is the tweet, and then it simply push the tweets into the tweets variable, right? So these are just like very simple, intuitive data structures, right? So one thing that you might notice, though, is that the tweet function doesn't accept a sort of like a user parameter, right? It's like you're not actually telling tweets, so like whose tweets you're tweeting. So the way this works is that we're actually using this global magic variable called message.sender. And what this is telling us is that we want to be storing the tweets under whoever that called this function. And we know for sure that it's that person because Ethereum, like all other blockchains, are secured by cryptography. Which are some of the things that Alex mentioned, right? So basically the idea here. So basically the idea here is that you can only be tweeting for yourself, but not other people. So this like very simple like 8 or 9 line smart contract is all that we need to build a decentralized Twitter. So if we run this contract through the Solidity compiler, it compiles it into a JSON object that can look like this.
I'm sorry, what was the name of the language?
It's called Solidity.
Solidity?
Solidity, yeah. Solid and then the T.
I mean, is MSG, is that reference directly to like a library of some sort there?
I don't think so. I think that's just the name of the language. Yeah.
Yeah, it's
I
like
know MSG, the MSG is like a global variable.
Oh no, yeah.
That's a global variable.
Yeah. And MSG is just a global variable that's available to every contract by default.
Okay.
And MSG sender is telling you like who sends the message. Cool. Any more questions? Go.
Like tweets which is public, like is that like read only or like can you write to it because like you can only call the functions or can you actually just write to tweet like the thing that is accepting this interface?
So you can just like write to a public variable, but but anyone can call a public function.
Okay, so you can't write to a variable directly, like
right,
so you have
right, you
function.
can, yeah, right.
Okay,
Yeah,
so
that would be extremely insecure.
Okay, so you can read the list of tweets.
Mm-hmm.
Okay.
Right, that's right.
What does view mean?
Which one? View?
Public view.
Oh, I see. So the view keyword here basically just says that this function is a read-only function, saying that it's not really changing the state, and the compiler can do some optimizations based on that. Right. Cool. Any more questions? Right. So if you run the smart contract through the Solidity compiler, it compiles it into a JSON object that has like the following fields, right? So it has the contract name, it has the ABI, which stands for Application Binary Interface, which basically tells you sort of like what are the functions that you can call. So here you see that you can call tweet. And so it also has a bytecode field, which is sort of like the actual code that gets deployed on Ethereum. Basically, like the idea here is that you don't want to tie Ethereum to any particular program language, right? So like as long as your program language can be compiled into this bytecode format, it can be deployed on Ethereum. But Solidity just happens to be like the most popular smart contract language these days.
So is there like an algorithm that you can implement in like Clojure to compile to?
Yeah, for sure. Yeah. So if someone wants to implement like a Clojure to Ethereum bytecode compiler, that's totally possible. Yeah. Alright, so we'll be, okay, so now the next step is that we're actually going to be deploying the contract on Ethereum through Rebel, of course, because we're using Clojure. Alright, so now it's getting into Rebel. So here we'll be using this library called CLJS-Web3. By the way, like, does anyone here work for this company called District 0x? Does anyone? Oh, you do? Wait, are you by the way like the founder of the company? Or? Yeah. So yeah. Okay. Yeah. Hey, nice to meet you. Because District 0x is actually like a company that wrote most of the Clojure libraries for blockchain development in this space. And I think the founder is actually the person who wrote most of the code. So thanks.
Good thing you identified him before you said anything bad.
Cool. So let's just go ahead and import the library. Can you see the thing?
Yeah.
Alright, so we'll be comparing it. Very easy. So now we will be initializing the Web3 object. So here, by the way, I should probably clarify that I'm running like a local copy of Ethereum, which is a thing that people usually do when they're developing decentralized applications. Because like we don't want to actually be spending money to like deploy on a real network, when you are just like doing development. And here's like sort of like the graphical interface to this like local Ethereum network. As you can see, it sort of like gives me an overview of like all the accounts on the network, and you can see the transactions. You can see the blocks, right? So it's just like really fancy and useful thing. Right. So now we'll be initializing the Web3 object. And then the next step is that we will be, sort of like just like querying the accounts, just to show you that it's in fact possible to interact with the blockchain through Clojure, right? So here we'll be doing like so here we're just calling this accounts function, which takes the Web3 object that we just initialized. All right. Well, I guess I have to print it. Sorry. All right. Well, okay. So here you print this a list of accounts. And finally, and lastly, we are going to be actually deploying the contract through Repo. So here, basically, what I'm doing is that. So here, basically, what I'm doing is that I'm calling the contract new function, passing the Web3 object, and then passing the API and the bytecode that I just showed you earlier, which I've stored in these variables. And here you might notice some weird arguments such as gas and gas price, which we are probably not going to get into for the purpose of this presentation. But just know that it's sort of like a way to specify like how much Ether, which is like the Ethereum currency that you want to pay, for this transaction. Right. So we just deploy the contract. And now we can look at this local, like blockchain interface to figure out what's the address of the contract that we just created. So here you can see that we have a new transaction that has a hash, and it also has a created contract address here. So we will be copying the contract address for later use. Right. So now I'm actually going to be giving you a demo of the decentralized application itself. So like I said before, a decentralized application is really nothing more than a normal application that happens to interact with the blockchain. So here I have like a very basic web app. I didn't spend time to start it at all. So excuse anyway. Yeah. So the first thing I'm going to do is that I'm going to paste in the contract address that we just that we just deployed. So one thing to note here is that like normally if you're actually developing a dapp, usually you would have deployed the contract beforehand, and you would have hard-coded the contract address into your application so that your user doesn't have to sort of like paste in the address of your the address of your contract. The only reason why I'm doing this right now is just to show you that I can in fact deploy a contract. Right. So I'm going to be using this contract, and now we're going to be tweeting. So I'm going to just like write some tweets. So I'm going to say hello Clojure. Right. We're going to click the tweet button. Actually, I should be using Chrome because like the Firefox MetaMask plugin is actually buggy right now. So we'll be using this contract, and I will be tweeting hello Clojure. So one interesting thing that happened here, which I hope you can see, is that when I click the tweet button, MetaMask actually shows a pop-up that asks me to confirm this transaction. And the idea here, the idea here is that every time you interact with the blockchain, you have to pay some sort of like currency, right? And MetaMask and MetaMask sort of like tries to protect you from accidentally spending too much money in malicious applications. So here is asking you to confirm that you in fact want to spend like this much gas and this much gas price as part of the transaction. So if you think that all the numbers look reasonable, you'd be clicking submit, otherwise you'd be clicking reject, in which case no money is spent. So here we do submit. And hopefully actually let's try again. I'm not sure where we're on. Actually let's go to our little blockchain GUI. So here we should see a transaction that's been created, but we didn't see it for some reason. That's weird. Right, let me try again. So let me just make sure that I actually log into MetaMask. So here it would seem that I did. Let's try something different. Maybe they don't like the word Clojure. Hello, Pascal. I'm sorry.
Try something non-functional.
Sure.
Sooner than ClojureScript.
Clojure.
That one.
There you go. See?
It's actually looking very different. Oh, interesting.
So Java worked.
Yeah.
No, it actually didn't work because it didn't even ask me to confirm the transaction.
Oh, I thought it was.
Right, let's try this. Submit. What's happening? Alright, how about we just like visit the tweet page of this account just to make sure that maybe the transactions actually went through and it's just that like the UI is not showing it. So in another browser window, I'm gonna be visiting like the account that I was just using. So hopefully it shows me some tweets. It's not showing the tweets. Annoying. The finder, please fix. Whatever, it's also not my fault. Alright, so why don't we try to refresh the page?
Well, so that wasn't part of the API though, right? I thought the API just said you could get the count of tweets or something?
No,
It was that link.
Oh, sorry, what?
It said to publish, but the other one, the view, was just the dot link.
Right, yeah. But yeah, so
when you mark those instance variables public, it makes getters for you, which is what this thing will do.
Yeah.
Maybe just try refreshing it.
Yeah, I mean, yeah, if we go back to smart contract, we have this tweet function, which is what the tweets button is calling. Right. Refresh.
So in a real dapp,
Sure.
we would actually be writing some small bit, 10 bytes of tweet data to the
To the blockchain, yes.
And it would be there forever.
Yeah, how's
Yeah,
that?
yeah, right, yeah.
How's that going to scale?
That's sort of like the $1 billion question that the blockchain community is trying to solve right now. Yeah. So if you can solve it, you guys are like a billionaire right now.
Isn't it going to get really expensive over time to write messages to the blockchain on Ethereum?
Yeah.
Really do it for like really important things.
Yeah, that's a good point. Yeah, it's actually being observed that like the Ethereum's transaction price has been going up over time.
Yeah.
Right. So basically so like a race between like people using Ethereum and also the Ethereum developers trying to scale the blockchain, to see who can to see who's faster. Right. So just refresh the page. Let's try this again. If it doesn't work, it doesn't work. I mean, it's really just a tweet application. I'm sure you can trust that. It works. At some point. All right, we'll be using a contract. So. Hello. Okay, why is MetaMask not even asking me to? So one thing you find, like when you start developing the app, is that like the ecosystem is kind of broken, in the sense that, I mean, it's true, because Ethereum itself actually wasn't sort of like started until 2015, and like the surrounding developer ecosystem around it is actually very much immature right now, which is why you actually run into like really fundamental bugs. I mean, as in like when you are developing something like a normal desktop application, you wouldn't expect to run into like a Linux kernel bug usually, right? But when you develop a dapp, it's actually a pretty common experience to run into bugs in some of the most fundamental technologies like Ethereum itself. So it's actually really cutting edge, exciting kind of activity, which is what I should be doing. Alright, so I'm gonna call this a loss. But the idea is that like the tweets should be showing up here, and then we should be able to visit the account, in another browser window. Cool. Alright, so just demo. Alright, so before I actually showed you the ClojureScript codes that makes this possible, I actually have to spend a little time talking about this thing called reframe, which I think some of you might be familiar with. It's basically one of the more popular ClojureScript front-end frameworks. And the way it works is that when the user does something in the UI, an event will be dispatched, right? So it's like if the user click the tweet button, an event called tweets will be dispatched. And you will write event handler in ClojureScript that handles those events. And the event handlers will be outputting something that they call effects. And what effects are is that it could be either internal effects, meaning that it's effects that changes the state of the application itself. So like if you are writing like a counter web app, then like then the application state would be like the actual counter, right? Whereas like an external effect would be something like writing to the email, writing to database, writing to cookies, writing to local store. So here the idea is that we'll be writing event handlers that handles the UI events and then generate effects that interact with the blockchain. So here's sort of like the most relevant part of the code. I'm not actually gonna be walking through the entire code because that's like too much. But the core of the code is here. So we'll be importing this like library. Like the most important library here is this one. refriend.web3.fx. And the way it works is that we're essentially saying that okay, so for every tweet event, we are gonna be returning a data structure that describes that sort of like describes the interaction that we want to happen, for the to the blockchain. So here, if you look into this data structure, it's really just a normal Clojure map that that takes like the Web3 object, that takes like the contract instance, and then it calls the function tweet, right, which is the function that we wrote before. It takes it as an argument like the text, and then it has like all the other parameters like guess and whatnot. So as you can see here, right, like we are actually sort of like not directly calling the blockchain's functions as we did in the repo. Because I recall that when we were in the repo, we actually interacted with the blockchain by directly calling the functions. And the reason like why here we prefer to be returning the data structure as opposed to just calling the Web3 functions directly is to essentially make the event handlers easier to test, right? Because like if the event handler is simply returning a map, then it's very easy to verify that your event handler is doing the right thing, as opposed to if your event handler was actually calling into the blockchain directly, then it becomes very hard to test because like how would you know that they actually did the right thing, right? You have to actually sort of like have like a local blockchain, and you have to actually sort of like check whether the thing that you want to happen actually happened to the blockchain, right? So by returning this very simple map data structure, like we end up writing the event handlers that are very easy to test, and that's again, like thanks to the District 0x guys, for writing the library that will actually turn this very simple data structure into a real Web3 course. Cool. So that's the code. So now let's recap what we just built, right? So even though like there was like a really simple Twitter clone, the Twitter clone actually already has some properties that a real Twitter doesn't have. For one, like the Twitter clone is totally unstoppable, meaning that no one can shut down the Twitter, right? So it's like if Twitter the company goes bankrupt tomorrow, or if like maybe like the US government is mad at Twitter, then they can just shut the company down and everyone's tweet will be lost, right? And no one can tweet anymore. Whereas this Twitter clone runs on Ethereum and by extension, runs on sort of like a global network of computers. And technically, as long as like there's one single computer left running, the Twitter is running, right? And then the second property is that the Twitter clone is totally uncensorable, meaning that no one can decide to not let you tweet, right? I mean, like if Twitter doesn't like you, they can block your accounts, they can filter your keywords. But for this Twitter clone, like no one can stop you from tweeting because there isn't like a centralized authority, right? And then like the third and probably less obvious property is that it's also spam resistant, meaning that right, it's just like very hard to spam because you actually need to pay some ether to tweet, right? So a spammer can't just create 2 million tweets for nothing because they actually have to pay the tokens to tweet. So
quick question: in the contract, would you specify how much it costs to tweet to save that tweet, or is it just like executing the contract costs something?
Right. So basically, you can sort of like as the dapp developer, you can in fact sort of like specify like how much like each function costs, but you don't have to. As in, this sort of like depends on like whether you want to earn money, right? As in like if you just want to be publishing some sort of like an open source like non-profit kind of like smart contracts, then they wouldn't actually be charging anyone. And the money that people pay actually just goes to the miners that Alex was talking about. But you could also, in your function, you could also write something like, like the sender has to be also sending me this much money at the same time for the function to go through. And that's some logic that you can build into the DApp if that's how you want to make money.
And does it, so everyone stores a copy of like the list of tweets, right?
Everyone in the network, yes.
Everyone in the network.
Right.
And then if you're gonna pay someone, do you pay whoever receives your message to store the tweet, or
It's whoever they happen to mine their block, they include in that transaction.
So in the contract, would you be able to say, I can take no money, or if the user wants to donate, is that something that you could do at the contract time?
Sure. Yeah. So you can sort of just like check, if the money is greater than 0, then send it to me, otherwise do nothing. Yeah, sure. Yeah, you can do something like that.
Oh, so that when they tweet, they would be given that.
Yeah. So like I can actually show you. So even though the demo wasn't really working, I can still show you this part. So
Reboot.
right. So basically, like when you click the tweet function. Right, so when you click the tweet function, MetaMask should be asking you. Sorry, I should be using. Well, I guess both browsers are working, but usually you sort of like so remember how like when I click the tweet function for the first time, it was showing me a form, right? And one of the fields in the form is basically just like how much money you want to attach to the transaction.
So if there was a specified contract amount, would that be editable still? Like, would you be able to get more if you? So like if they specified I want a certain amount of gas or ether. Would you be able to specify more? Or is it kind of locked in to the contract creator's price?
So the user themselves decide how much money they attach to the transaction, and no one else. But you as a developer can decide to not accept the transaction if the money is not enough or something.
Okay.
Right.
Now, there's something separate, but the gas is a little different from the transaction.
Right, yeah, totally. Yeah. So basically, like the gas is the gas is sort of like the amount of money you pay to the person who happens to mine your block, whereas like the value is sort of like the money you attach to the transaction itself, and only the contract author can access.
So the gas is sort of like paying for the electricity.
Right, essentially, right.
To mine to run the virtual machine that actually executes the contract.
Right.
And the contract value, transaction value is different, arbitrary, and is dependent on.
Yeah, I mean it's sort of like you driving to a grocery store with like a backpack of money, and the gas is like the gas, right, that you actually drove with, and then the money is the money that you're gonna be paying the. I mean, I don't think that's a good analogy. That's what.
Yeah.
Coffee.
That's why it's called gas.
It's hit.
Right. So was the last slide? Was it check? Right. So without this pure clone, without this pure clone, has like all these nice properties. So why is ClojureScript great for developing DFs then? Right. So there are basically 2 points. One is that we get access to Repo, right? So we can like interactively interact with the blockchain. As I showed you before. And the second one is that you can interact with the blockchain through these data structures, right? And that way, like you end up writing really testable, really controlled code. Cool. Thanks. Yeah. So it's me. Yeah. Hopefully you learned something. But any questions? Well, yeah.
What does your company do? Yeah, I couldn't hear what you said.
My company. So my company is basically so like trying to build like a faster Ethereum. It's like faster, more scalable Ethereum.
More scale.
So you're not actually writing the contracts in Clojure yet?
No. I'm writing the contract in Solidity.
Is there anything that would prevent that from being done?
Not in particular. So actually right now there are I think 4 or 5 languages that can compile to the Ethereum bytecode, and one of them is actually called LLL or something, which is actually a list. So there isn't actually like a reason why Clojure can be combined to the Ethereum bytecode other than that no one's done it.
There's pyramid scheme too. Pyramid scheme, if you want to throw that.
That's like a language?
It's a scheme that compiles EVM.
I see.
No, that's a bad.
It was named on purpose.
Yeah, so like if you want to be writing smart contract in Lisp, you can look into LLL. implement this.
Ooh, it's less.
So I'm relatively new to Ethereum and Bitcoin.
Sure.
Thank you very much for the introduction, both of you guys, to this stuff. With respect to distributed apps in particular, what is the top 3 distributed apps that you have seen and you've used to date?
So if you don't consider like Bitcoin an app, I mean, would you consider Bitcoin an app?
Well, I mean,
in
you know,
this
the D apps that have the JavaScript front end,
I see.
Web3 JavaScript middle, and then pushes some data into the Ethereum blockchain and gets it out.
So I actually personally haven't actually spent any real money in any DApp, just because I think they was not, which is why we really need good DApp developers. But I think like the most successful DApp till today is CryptoKitties, which you might have heard of. It's basically sort of like a way to raise kitties on
But it's a game. I mean, it's Tamagotchi for Bitcoin.
Is the Brave based
The Brave?
on
The Brave is
That's not a.
Yeah.
Oh, that's not a. That's
Brave is a browser. No.
Right. The Brave is a browser with like a really, I think like a really innovative idea, which is that instead of like you visiting a website, the website show you new ads, and then the website paying the ad like owner. The way it works in Brave is that you visit a website, and you sort of like directly pay the website through tokens. So basically, just by virtue of visiting a website, you are sending the website some tokens.
So
And then
it
there's
uses
also like a
Ethereum?
new way for.
But that's an Ethereum.
Brave uses Ethereum?
I'm not sure if Brave uses
It
Ethereum.
uses some
Yeah, it's an
blockchain?
ERC20 token.
Okay, so they do that.
It uses what?
They use Ethereum. Brave uses Ethereum. Yeah.
For the basic authentication, and that's like the means of paying the ad provider.
Oh, cool.
Well, for providing content providers, I don't want to pay ad providers.
That's why you don't see the ads. You pay the ad providers.
Ads are content too. Sorry if anyone hears an ad.
If anyone hears it.
Okay. So CryptoKitties.
So these are CryptoKitties. If you want one, you can pay like $10,000 to get one. But
So basically, we're saying that if this is the best DApp, the field is freaking open.
kids, yeah, which is why I'm doing this talk actually. It's like the money is everywhere, right? So you should quit your job.
So what do you say? Good job.
Yeah.
So, obviously, no one at this meetup would ever commit a bug, but for other people, how do you update an application?
You mean how do you update the smart contract?
Yeah, how do you change
Right.
logic?
Right. So that's actually another billion dollar question. In space. So the answer to Ethereum smart contract is that you just cannot. But actually what you can do though is actually something pretty smart. I can explain if you guys are interested. So basically in the smart contract, so even though you cannot update the code, what you can do though is to have a variable in the smart contract that says next contract. And what that means is that when you are ready to upgrade your contract, you deploy a new contract, and you set this variable, this next contract variable, to the address of the new contract. And then within this contract, before you execute any function, you're actually gonna check if the next contract value has been set, and if it has been set, then you will call that function instead. Then you will call into that contract instead. So sort of like a really hacky upgrade mechanism that
That can also grow without limit.
Right.
But then you have to pay to
Right.
execute two.
Yeah, totally, yeah. That's
Limited
yeah.
number of contracts.
Yeah, basically, yeah. That's basically like the downside to that.
But you can still choose not to, you just not charge them, right?
So what's it?
You could just not charge them.
Well,
Because you choose how much.
So as a developer, you can decide to not charge them, but they still have to pay the gas. So remember how they still have to pay the miners.
I have a question. This might be a little bit too far out of scope, but so like, how do you see the ecosystem of decentralized apps becoming like a thing that's widely used? Like, it seems like today people go to web applications and they expect to use them for free, and so maybe like you see like people getting tokens for things they do online and then using those tokens for other things, or like how is it supposed to? How is the everyday user who maybe doesn't have much money to just put their credit card in and buy some Ethereum? You know, how do they get in? How do they start using just random casual applications?
Yeah, so how you're making money through a decentralized application is another $1 billion version. You know, I mean, it's basically just I think so basically like the most obvious model obviously is just that like your function literally charges people, right? It's like your function will literally reject them if they don't pay you, basically, right? But that's obviously like you notice not very like good, just because like most people they don't expect to be paying things, when they just use your app. So some other less obvious ways to do it would be I'm sure you guys have heard of like this term like shitcoins, right? Basically just like people making random coins, right?
What's the word?
Shitcoin. Yeah. It's basically just like a word for like just like random coin that doesn't really have.
Must be another $1 billion.
Yeah, basically, yeah. I mean, but basically like the business model behind shitcoins is that you sort of like get people to buy into the hype. That's your shitcoin is going to be the next big thing, and then you don't invest, and sort of like make money by virtue of holding a lot of shitcoins.
It seems like a way to destroy the ecosystem. It doesn't seem like a way to build it.
That's like slash and burn agriculture.
Yeah, but that's like how you have been making money so far. So.
Trump coins.
Cool. Right. Yeah.
As a front-end engineer, I'm like interested. Are there any limitations of JavaScript as a language on the platform? I know it Web3 uses big num, right?
Sorry, could you repeat the question?
Are there any limitations you see in JavaScript as the platform and the language too? Because
I think is there any problems?
As a computational because
Limits.
it cannot natively represent big numbers, right?
Sure.
And Web3 uses big num, which is library, which is basically
oh yeah, that's true.
kind of a hack, right?
Yeah, that's actually a really good point. So like if you look into the dapp source code written in JavaScript, you actually see all this big number handling code for sure. Yeah. So that's one of the biggest drawbacks with using JavaScript to develop. Which I should probably put on a slide too, right? So if you use ClojureScript, you get free big nums.
I mean, I'm just mentally thinking, are we going in the right direction? As humanity, we're now we're calculating encryption using JavaScript. I'm a front-end engineer.
All right, that's the end of the talk. Great, everybody, give a hand to Derek.